Alright, hey guys, welcome back to the Tic-Tac-Toe Workshop. So for today, I'm gonna be going over just like a few kind of intro, like simple things about Java, um, things like arrays, loops, like how to use just a simple print statement. If you want to follow along, there is a something you can use called a JDoodle. It's actually just a browser online Java compiler. And you can use that to follow along, and that's what I'll be using to show you guys kind of what I'll be talking about. Um, I have a link for it in the Tic-Tac-Toe Discord, and you can also just Google JDoodle Java and follow along through there. But yeah, so as always, we'll be meeting here at 5 to 6 p.m. And yeah, let's get started. So as I said, you can follow along using JDoodle. So when you open up, at least with JDoodle, it actually gives you the starting template for a Java program, which is the main class and the main method. So this public class, my class header is your class header, and it's actually where Java looks first to look for where to start the program. This class header has a name, my class, and if you're writing your own Java programs, you might know or might have experience with the fact that this class header actually has to match the name of the file in order to run because Java uses that to determine which class to start at. And this public static void main string args is your main method, and this is inside of that is where the program starts to run. And once it gets to the end of that statement, that's when your program ends. At least for our purposes, we won't have to worry about return statements or exiting the program early. Um, for our purposes, we'll only be working with a single method. So everybody starts programming with hello world with no matter what program you use or language. So we're going to start with that. So Java's print statement is simply, well, I mean, not very simply. Java has like a kind of weird print statement. It's system.out.print, and the uh, the parentheses signify that it's a method. So I'll go over JDoodle right here. When you open it up, it'll look like this. You can just get rid of the code that's already there, or run it if you wanted to see what it does. So I'll write system print, and you can directly put um, different data types into this parentheses. Java has a few you might use as well. The main ones we use is just integers and strings. Um, Strings you can just put directly inside of a print statement with just using the quotations. So I'll just write directly hello world, and when we run this, it'll just print out to the terminal hello world. Um, let's see. Instead of you can also directly put variables into the print statement. So if you wanted to create a new string, Java is a statically typed language, which means that you have to tell it what variable data type your variable is. So you start with in our case, string. I'll just say str is a name, and the equal sign is the assignment operator, and I'll say hello world as the string. Java uses the semicolon as the delimiter for each line, to make sure you include that. Now we can just put str inside of our print statement, and it'll print whatever string is assigned to this str variable, which is the same. You can also, inside of your print statement, if you wanted to put multiple variables inside of a single print statement or something like this, I'll show you right now. If you wanted to concatenate, say like a number, Java's concatenation operator is a plus sign. And so what you can do here is we have our variable here. Since it's a variable name, you don't need the quotations. So right now I could just do str and then concatenate 1, 2, 3 next to it. And down here, notice that there's no space in between the string and the number. That's because the concatenator just puts it directly next to each other. It doesn't care about it doesn't actually put any spaces or anything. But if you wanted to put a space, what you can do is add a not an empty string. Empty string would be this. You would have a string with just a white space, and make sure to put another concatenation in between the number as well, between each individual part of the statement. And we run that, it adds a white space in between here. Let's see, you can also, oh yeah, we'll also use the print line statement, or print ln. And what this one does is, instead of printing just the line, just a single line, print ln will print a line and a new line, which means that the cursor is now under this line. So now if I print out that 1, 2, 3 again, it'll get printed under the hello world. And you can use this to kind of like format. This will be pretty crucial to us because we want to format our game board to look a certain way to be recognizable as a tic-tac-toe game. Let's see. And the print ln, you can either use it simply like that, or if you wanted to do something like this where you put, if you didn't have a variable, you just want to put a string or something, you can add the new line escape character inside at the end of your string. And what this will do is Java will read this as hello world, and this /n, it'll be read as like pressing enter on the keyboard, and it'll print a new line, and then anything after that will be on the new line. So as you see, it comes out the same. Right, so yeah, like I said, you can use the concatenation to combine multiple data types in a single print statement, which is useful for if you wanted to format how you want your print statement to look. So for our purposes, we'll be using this to print our game board. What we want at the end is going to be this, for it to look like this. And we actually have several different ways that we can go about doing this. One of them is going to be using strings. So a string is just a sequence of any characters, whether it be numbers, letters, symbols. Strings, you can actually combine each one, because when you create a string, it'll be inside of quotations, and no matter what, if it's a number or a letter, it'll be read as a string character instead of a number. So this makes it pretty useful to quote unquote to hard code in how you want your print statement to look. And hard coding is just a word that is used to describe when you make a value fixed, which means you directly give it a value instead of saying like 2 plus 2, you assign the result of that to the variable, you just make it directly 4. And what that means is that you can actually change, at least with a string, you can't actually change the string without directly changing it through the variable name. And I'll explain that just over here. So if we have our string str up here, there's no way to actually change that string unless we actually change the string by referencing the variable itself. So if I change it to like hi, and I print that, forget the semicolon. Oops, I forgot the semicolon. Oh, what else did I find? Oh, I forgot I deleted the comp thing. And now the string is up here, it's hello world, and down here it'll be hi. So you can actually change strings, but this is the only way to do that is to directly reference the variable itself. So um, where that's important is, let's see. So if we wanted to print our game board using strings, one way you could do that to kind of make it look nice and easy to understand, we just use a bunch of print statements. And this is what I meant by strings being easy to hard code because of the fact that you could just stick them right into the print statement. So exactly how it's formatted here will be exactly how it shows up on the terminal. And say if you wanted to change this to X, I would just change the string itself. You can also like assign, instead of hard coding in the string, you could assign this like line 1, line 2, and then change them like that. But for us to make it easy to kind of see, now I changed that value up here and it's changed down there. So yeah. Another way we can implement printing our game board is using arrays. Arrays are actually pretty important to not only just Java, but a lot of other languages use arrays. They're probably like one of the simplest data types to learn, but also one of the most commonly used and like best to kind of get a grasp on. Array is just think of it as a container of one single data type. As I said, Java is statically typed, which means, again, you have to tell Java what data type you're going to use. In our case, I'll tell it that I want to use a array of integers. So I say int, that's the data type keyword for integer. And I give it a name for a variable. I'll just say nums. And the way to tell Java that you want to use this as an array is the open and close brackets. And if you want to directly assign what numbers to put inside of each spot in the array, you just use curly braces and each value separated by a comma. So the one thing that's a little bit confusing about arrays is the difference between the array's length and indexes. So for us, we have an integer array that has 5 values. So that means the array length is 5 because it has 5 values. But if you wanted to pull this number out and change it or whatever you wanted to do to it, arrays are indexed starting by 0. So if you do nums index 1, it would actually return the number in the second spot because it's actually starting at 0. If you actually wanted the first number, if you wanted 1, you would have to say num at index 0. And if you wanted the last number, in our case, since the length is 5, it would have to be 4, the index for 5, because if you try to reference the index 5, it's actually outside of our array, which means that you'll get index out of bounds error. And the other thing about Java is that its memory is statically allocated, which means it actually determines how much memory to give this array, and you can't ever change it. Meaning, like if you wanted to add something to this array or take a number off, you wouldn't actually be able to do that without this being like a null character. The length is always going to be the same. So if you actually wanted to add a new number or take off a number, you would have to create a whole new array. But for our purposes, we won't have to worry about that. We'll just be worrying about like how to change each individual number. And the method in order to get how long this array is numbers.length, and that'll return 5. So if we wanted to use that for our game, what we can do is do it similarly to the string version, but instead of going in and changing the variable each time directly, we can use an array to kind of keep track of each number in each of these spots. and then just kind of format how we want it to look around the numbers. So up here I tell Java that I want to make an integer array, give it all the values 1 through 9, because we only really need to worry about changing the numbers. We don't have to change the board at all. So similarly, I'm just using a bunch of print statements to print the board. And just like we learned earlier, we'll use the concatenator operator to print these first two characters, and then we print the number at index 0, which is 1, all the way up in each spot until we get to index 8, since at index 8 the number is 9. And one easy way to kind of make that part of the arrays a little bit easier is the fact that the last index that you can reference is always going to be the length of the array minus 1. So let's say if you wanted to find like what index, if you have this giant array, you want to find out what index this 5 is at least for us, since we have it going 1 through 9, you would take that number and subtract 1, and as you see here, it's at this middle number spot, and that number is 4, so it'd be 5 minus 4. 5 minus 1 is index 4, just kind of to make it a little bit easier to kind of see the difference between index and length. Alright, so when you run that, it'll just print the game board, and instead of so say if I wanted to change this number to like 10, I can change that in the array, and down here it'll change that number in that spot. And also, since we directly hard-coded in the formatting of the board, it'll reformat itself around whatever number you put in there. So that's another way to do it. The last way I'll talk about doing it is using a two-dimensional array. 2D arrays are kind of confusing if you've never seen them before, at least in programming, but if you think of them as like a matrix in math, it kind of makes it easier to understand. So in programming, 2D arrays are basically just an array of an array, or arrays of arrays. So in this case, you can actually, so this first 1, 2, 3 array is one single array. The next one, this is going to be 3 arrays of 3 numbers, and you can kind of, each number goes into a each one of these spots if you kind of think of it visually. Oh yeah, to tell Java that you want to make a 2D array, you would the same way tell it what data type, the name of your variable, and actually put 2 open and close brackets to show that you want to make a 2D array. And to give them the values, you would do the open brackets like we did earlier, and at the end of your open bracket, when you want to say this is the end of the first array, you put a comma. And you can actually write this this way in Java because it ignores the white space until it gets to actually messed up that part. That's supposed to be a semicolon. So let's see if I do if I give this first array values of 1, 2, 3, I can actually just, instead of writing all this on the same line, you can actually make it easier for yourself to read and for other people to read if you can do it this way. Just make sure to have the comma at the end to to show that you're starting a new array. And 7, 8, 9. At the end of here, you write a semicolon because Java will actually read all of this as one line. It actually ignores all this white space until it gets to your line delimiter, which is the semicolon. So similar to arrays, the way to reference them is having a number inside of these brackets. So to kind of see them a little bit easier in your head, you could think of the first bracket as what row you want to look at, and then the next bracket what column. So if you wanted the row 0, column 0, it'd be this spot right here, which corresponds to 1. And then if you wanted row 1, column 2, it'll return 6, which is this number, since it uses the same indexing rule of starting at 0 for 2D arrays as well. And one other thing that will use is, as we said earlier, nums.length in an array returns how long the first array, how many numbers are in the first array. That will return 3. And as well, you can also reference this first array using nums0, which basically takes in the first array, and you can use the .length method on that to give you the number of columns, whereas just the regular .length gives you the number of rows. So we can use that to, let's see, where is it? Okay. Yeah. We can use that to print our game board by, I'm actually going to use characters, since char is another data type in Java that will just recognize a single symbol instead of strings, which is a bunch of characters. It'll just recognize one character at a time. So this looks kind of messy, but it does the same thing of printing the same board, just individually by character. And I'll explain kind of how for loops work, but this will print each individual character one by one, and that's how we would use 2D arrays to print our game board. And the advantage of this is being able to not have to worry about iterating and finding exactly where we want to change this number. If you can kind of tell this is going to be row 0, this is row 1, this is column 1, column 2, column 3. If I wanted to change this, I would just say game board. I would put row 1 and then column 2, and I could just change that value directly. Alright, so for our purposes, we want to print the game board, but we also want to be able to update it. Every time somebody makes a move in the game, we want to be able to change the value in whatever spot they pick. So since we have 3 different ways to print the game board, we'd have to use the same way to update it. So if you wanted to do string, you can just update the string, but if you also wanted to compare, like on this last picture, we want to be able to recognize on the board if there's 3 in a row at any point. If at any point 3 values in a line are equal to the same value, which in this case would be x. So if you wanted to do that with the string, you would have to use the substring method. With the array version, we would just directly index the array, as well as with the 2D array, it would just be 2D indexing. So substring is a method that you can use to pull out parts of a string. String is actually an object, meaning it's not actually a primitive data type in Java, which is why it's capitalized. It's actually an object. And for this reason, to perform certain operations on it, it has methods, which are these dot equals and dot substring that we're going to use. If you wanted to use these methods, you would put, at least in our case, what I used earlier, I'll just keep using str. So if you wanted to use a substring, it'd be str.substring. So the first number in the method, the first argument that you give the method is a starting index, and the next one you would use is the exclusive ending index, meaning since this substring actually goes by the same indexing rule of starting at 0. So if you wanted to get the entire string, you would say, at least for this example, you would start at 0, index 0, and end at 7. Since there's no 7 here, substring is exclusive, meaning that it will exclude the 7 and only go basically 0 to 7 minus 1, which is 6. If you wanted the just at one point, um, if you wanted to start here at the G and print the rest of the string, you don't have to give it the ending index. You can actually just give it just the starting index, and it'll print the string after that point. If you wanted a certain piece in between the string, that's where you would use the two values. In this case, you start at 3 and at 6, and it'll give you 3, 4, and 5. Substring will always return a string, meaning that if you wanted to compare, for us, if we wanted to compare two spots on the grid, we would use the dot equals method, which same way you would use, in our case, I would use str dot equals, and then whatever you put in here is whatever string that you want to compare it to, and this method will return true or false. Now, that was a little bit of like a step up in complexity just because of the methods, but what you really need to know is just the main thing you want to know is string is an object, meaning that it uses different ways to compare to compare each other. And for us, let's see what it is. If we wanted to update this board every single time and compare each part of each of these numbers, we can actually keep using this system out print over and over because we need to update the string values. So instead of this, what I'm going to do is assign that entire string as a single string into a string variable. So I'll call it game board, and we're going to use what we learned earlier, the new line character, to show Java that we want to make we want to skip a line. So if I run this, oops, hold on. This will actually print the same way. It just kind of looks less appealing because it's on one line. But now we can actually, instead of keep writing this over and over, we can just directly interact with this game board string. The problem is that since Java, as I mentioned, is statically typed, strings are also, statically memory allocated. Strings can't actually be changed, like I said earlier. So if you wanted to change the game board to, say, change this 3 to be a new, to be, say, like an X, you'd either have to change this and do that basically every single time, which is not practical for something that we want to run constantly. You would actually have to create a new string, or change the string itself. For right now, I want to print both of them, so I'll print both of them. Oops. Oh yeah, and then this is kind of where the print ln is useful to kind of help with like formatting the how you want the board to look. Got the /n over here, and this will print the first board, and this will print the second board. So the problem is trying to, not really printing the string. Strings are actually pretty easy to print. The problem is trying to compare a string. We can actually, as I explained earlier, you can use the substring method to do that. But the problem is trying to figure out what index each of these numbers are is going to be kind of annoying. But for, so I did the work ahead of time, and this is where I'm gonna use 3 as the example to change to an X. So down here, this line is gonna print this number 3, and then this line is gonna print this X because that's the substring position I'm basically this character right here at this where the cursor is 24, and I'm delimiting it with 25, meaning I'll only print whatever's in this spot. Using the same number, I can get whatever's in that spot on this string. And we can use the dot equals method that we used earlier. So this whole substring is basically just going to be referencing this 3. So if you think of this as just being 3, you can use an if statement, and as I explained, strings use the dot equal method, and this is going to be referencing the x. So if that's true, then what I'll say is print true. Oh, wait. So, hold on. Oh yeah, make sure to count your parentheses because you get a lot of problems. Where would I end up print? Oh yeah. So since these two aren't actually the same, they don't equal the same. Substring returns a string. So this first one is returning a string of 3, and this next one is returning a string of x. If they don't equal each other, then we're gonna print false, and that'll kind of prove that these two numbers are not the same. And then if I change this to, oops, if I change this to 3, oops. Yeah, it'll print true. Alright, so that was for at least if we wanted to use a string to implement our game board. If we wanted to use an array, it's quite a bit easier since we only have to worry about the array. We don't have to worry about the all of these extra formatting characters. What we actually use to change each number in the nums array is what we learned earlier about indexing with an array, which is just referencing each number by its index, which makes it a lot easier to get to where we want to when we want to change something. So what I can do is I'm actually going to change this to be a character array of characters because let's see, I want to change that to be, wait, I think you can actually do this without using characters. Yeah, you should be able to. Oh, actually, that's right. I want to change this to. Oh wait, hold on. Oh right. So, I'm changing it to characters because this isn't just going to be numbers. This is also may or may not be an X. So I'm using characters, an array of characters, because I may or may not want to change this to an X. So I can't use X as an integer because that's not an integer. So what you can do is, after printing the first board, you can take in the user's, say the user wants to say, like, I want to change this 3 to an X. We can take in the input, I'll call it user index, and just say they want to change number 3. And then I can use, well, I'll set their symbol, say that they're playing as X, so they want to change that number to X. I'll just save that as a character so I can reuse it later. And what you would do is reference nums. And instead of directly putting 2, what you can do is, like I explained earlier, you take the index, or you take the number and subtract it by 1, and that'll give you the index at that number. So I could say user index minus 1, and that corresponds to index 2, which is 3, which is what we want. And then I'll change that to user symbol, and that corresponds to x. So what I'm doing is basically changing this 3 to an x character. And so I'll reprint the game board after doing that. And now we change the 3 to an x. So now you can kind of see that you can, it kind of makes it a lot easier to change the game board using arrays. If we wanted to, I'll do that again. Let's see, I have it copy pasted. If we do that again, and then, whoa. And then say we want to change 6, which is this right here. What I'll do, all you have to do is just change what index it is, and now it'll change. All right, since we already declared the variable, we don't have to give it the data type name anymore because it's already been created. We could just use the variable name itself if we want to use it again. And now we change this 6 to an x. And so that's how we'll update the game board each time the user changes something on the board. And if we wanted to compare those two spots on the board, I'll use an if statement, and I'll reference 2 because that's the index at this 3. So if that 3 is equal to the character, if this x is equal to that character down here, then it will return true. Oops. And then else, it'll return false. So if those two x's are the same, it should print true at the end, and that's right. And say if I change this to change something else to x. What did I changed this 5 to an x, and now when it tries to compare these two spots, it returns false. So you can kind of see how you kind of see the the basic kind of idea of how you would check if you had 3 x's in a row. Next week I'll talk about methods and how you can kind of shorten this to a lot less lines and kind of make it less scary to look at. For now, let's see. So with 2D arrays, instead of, oh yeah, so for loops are what we're using here to print this game board. For loops are kind of similar to while loop, where you have in this case we're using a counter, which is this I variable. We create this, set it to 0, and this kind of keeps track of how many times this has ran through. This I is less than 10 will be checked every single time the loop runs. We'll check if I is less than 10. And then the I++ is incremented every single time we run the loop. So say in this loop, we set I to 0, it runs once, I gets incremented to 1, and then it checks if 1 is less than 10, and it just runs that until I is equal to 10, which this becomes not true. And the kind of convention we use is having I equals 0, and then however many times you want the for loop to run will be this number right here. So if we want to run it 10 times, we'll put 10 here. And you can also, that just kind of helps keep track of how many times the loop has ran. And you can also use it using arrays to keep track, to use it as a iterator for going step by step inside of an array. And we use for loops because we know exactly how big our what's it called, our game board is. So for loops is kind of best for us to use. So in this case, as we explained earlier with 2D arrays. The first number will be rows, and the second number will be the column. So instead of um, using I for this, we'll use row just kind of so you can recognize it. Gameboard.length will be how long one single array is, and that'll be how many rows there are. And yeah, row plus plus is the same as I plus plus. What you can actually do is do what's called nesting a for loop, and that's when you put a for loop inside of a for loop. See how this parenthesis belongs to this for loop, and this one has these two. So for every row, what we're doing here is at each row, we're doing the same thing. We're going column by column, and then we go to the next row, and then go each column, and that's kind of how we print the game board, just going one by one, going to the next row, going one by one down, and that's just kind of how. That's maybe like you could see that as like a downside or like an upside to using 2D arrays, but the fact that you have to print each thing one by one. But one advantage of using 2D arrays is the fact that you can directly reference similar to regular arrays. So let's see. Same way that we did before. I'm gonna take integer user index, which is the number that they want to change. I'll say 3 again, and then that's it. Character user symbol is equal to x, which is whatever they're playing as is x. And then so what I'll do is pretty similar to referencing arrays. I'll do gameboard is the name of our variable of the 2D array. So I'll reference that, and then there's kind of some math that you can do to figure out exactly what position this is, but for now I'll just kind of hard code it in because it's a lot easier to explain. So this row is row 0, this row is row 1, since we can start counting at 0, so this is at row 2, no, row 1, I lied. And then for the column is going to be, what was it? It's going to be 10. So at column 10, that's where the 3 is, at row 1, column 10. And we're going to reference that and then change that value to user symbol. And then we're just going to use this. The for loop you kind of don't really need to understand right now. Just know that that's how what we're gonna use to print this. I'm gonna add a print line right here, so just like as another example of formatting you can use to make this look nicer. So now I did the exact same thing. All I did was change the 3 to an x, and we'll do the same thing again, but all I'm going to change is, I'm just going to change the index to be 6, and then I'm also going to change, I have to tell it where that 6 is in order to change it, because if I don't, it's just going to change the 3 again. So we'll do game board, that is row 3, column 10 as well. Oh yeah, then I don't need to have the data type there anymore. And now first we change the 3, and then we change the 6 to an x. And we use the same if statement to compare those two values. So what I'll do is I'm just gonna paste this. So if this 3, I'm not down here, if this x is equal to this x, then I will print true. And that'll print true, and if not, then I'll print false. And if I change up here, if I change this to 5, so it'll change the middle number again, it'll print, why did it print true? Oh, because I didn't change this variable. What is that? I'll change that to, I think that's 7. No, wait, 3, 4, 5, 7, I believe. It was 6 actually. So now I change that 5 to an X, and now when it tries to compare this spot and this spot, it returns false. So this is just also another way to implement the game board. So that was kind of a lot. What I wanted to show you guys was basically just that there's a lot of different ways to go about solving certain problems. I mean, it doesn't really the main thing that what matters is if you're working, so in our case, since we're working in a team, we want our code to be readable and easy to understand for other people. Using things like this, like using variable names that are self-explanatory, like nums will represent numbers, variable names, and using spacing out your code and blocks will kind of tell you that like this does a certain thing, this does something else. Things like that will kind of be what you want to look for with kind of what we want the board, what implementation we want to use for the board. So what I want for you guys to do is try to think about like what implementation of the three would actually be the best for us to use. What you want to think about is how readable it looks. JDoodle actually has you might have seen it, it has how long your program executes for and how much memory it uses. You can also look at that, see like if one takes longer or if one is, has like trade-offs of being less readable but goes faster. And also future proofing. What I mean by that is how easy it is to implement certain things. Like for us, would be implementing the big one for right now is checking 3 in a row. So something like string might not be the best for that because it's going to be hard to reference all of these one by one. So you look at that and you can drop in like one of the chats and say like which one you can actually code this up yourself if you wanted to and like finish the code and see how it works. You don't have to do every single case. If you do like 3 in a row, that'd be good enough to kind of see like how we would do it. And then eventually we're going to be starting to work on implementing this as either a web app or a mobile app. So anybody that's interested in making designs or is good at art or like gets bored and draws stuff in the notebook during physics or something, you'll you can start dropping in designs in the Discord, and we'll also if anyone wants to start researching app development using something that actually takes Java, something like Spring Boot is actually really good. Docker is another one that's a little bit more complicated, but we can actually start looking into how we're gonna actually implement this as an app. But for right now, for next week, I'll just talk about methods, which will kind of help make this a lot prettier to look at, and control flow, which is using if statements, switch case, things like that. And the main goal for this week, it was basically just printing the game board and figuring out what we want the best way for that to be. For next week, we'll try to implement how do we check for if somebody won the game at any point. So for now, just try to look at each one of these and either try it out yourself, try coding it yourself, or like drop in one of the tech channels and say like what which one you think is the best for like what reason, and we'll try to come together next time and see which one we're gonna go with. So yeah, is there anything that you guys are uh, any questions, any suggestions so far? I know this one was kind of long. I'm sorry. I'm probably won't be this long going forward. I don't imagine it. Um, but yeah, we'll be. If not, we'll be back here next Wednesday. And like I said, I'll be talking about control flow and methods and a little bit more about Java's object-oriented capabilities. Oh, I can actually see. Sorry, I didn't see the chat till right now. I know it's not really Java, but will Flutter work? Flutter, I know. Oh, see that? If you want to look into that, that'd be really helpful because I know Flutter is pretty common used for mobile app development, and I think web development as well too. Uh, Flutter is using Dart, which is actually pretty similar to Java. Um, but I'm not sure if there's a way to get a Java app to work on there. If there is, like, it'd be great for us to know, like, if you can look into that. Spring Boot is one that I think will be actually useful because Spring Boot actually uses Java. Um, yeah, cool. And then whatever you find, you can drop in the Discord under R&D. And then, like I said, anyone else that wants to drop designs or write code or whatever, collaborate with each other. I also have the roles in the Discord as well for your name to be like highlighted for each other to see like who's working on who wants to work on what and who you can talk to about certain things. But for this week, that's it. Thank you guys for coming. Again, sorry it was kind of long, but see you back here next week. Thank you.